All right, let's talk about how we represent atoms in chemistry. Sometimes we like to draw them, and there's a model of an atom where we put protons and neutrons in the center, and we put electrons around that model. We learned that model before as Rutherford's nuclear model. Sometimes we represent them with numbers, though. The atomic number is an important part of this representation. Atomic number is another way to say the number of protons in an atom, and the atomic number is a number written on the periodic table. Generally, you find it at the top of each element's box, sometimes in the corner, and it's always a whole number. The atomic number is the number of protons, but it's also going to equal the number of electrons. Since we're talking about atoms which are neutral, this means the number of protons and electrons will be the same. So, how about this example right here? I've got neon. I'd like to calculate how many protons in the neon atom. Well, we look at the number in the top of the box. Since there's a 10 there, we know there's 10 protons, and there's also 10 electrons. What about this one? Tungsten. How many protons in a tungsten atom? Man, you are sharp. 74, that's right. And the number of electrons will also be 74. Excellent. Now this question's a little different. I want to know how many electrons in a chlorine, and I also want to know how many electrons in chloride. So I bet you figured out how many electrons are in chlorine. It's 17, right? The atomic number is 17, so that's the number of protons and electrons. But what about chloride? What does this little symbol tell us about this ion? Well, what it tells us is that this thing has gained an electron. That's why it has a negative charge. Therefore, chloride has 18 electrons. Excellent. All right, so that's atomic number. That's the number of protons. There's another number that we're going to be using here called the mass number. And students confuse this all the time with atomic mass. Now we'll come back to atomic mass later, but right now I want to explain what mass number is. The mass number is the number of protons and neutrons added together. So in this little model that I drew, the mass number would be 6 because there are 3 protons and 3 neutrons for a total of 6. Mass numbers have to be whole numbers. That's because you can't have a fraction of a proton or neutron. What this means is you can't really figure out the neutrons by looking at the periodic table, although you might make an educated guess. Let me show you what I mean. Let's focus in on this element here. So when you look at copper, copper has an atomic number of 29. That means it has 29 protons. This number down here that students sometimes confuse with mass number is not a whole number. It can't be a mass number. Mass numbers are the number of protons and neutrons. And you couldn't have 34.55 neutrons, right? So this number down here is not a mass number. It's a number that we call the atomic mass. And like I said before, we will get to that in our next lesson. For now, just suffice it to say this is a kind of average. So that's why oftentimes you find numbers that are not whole numbers. At this point, I want to show you one other thing that's kind of interesting about these atoms. Small atoms, like lithium-6 pictured on the left, tend to have about the same number of protons as they do neutrons. In other words, they have a 1-to-1 ratio. As the atoms get bigger, though, when we look at something like zinc with 30 protons, notice that this has 35 neutrons. We're no longer at that 1-to-1 ratio. Another way to say it is, we've got extra neutrons in this bigger atom. And as we get to bigger and bigger atoms, we're going to see this effect magnified. So why is that? Why the extra neutrons? Is this kind of a random thing, or is there a reason behind it? Well, I probably wouldn't have asked you if it was a random thing. Here's the reason. Think about this. As you get to bigger and bigger atoms, you are cramming together more and more of these positive protons. And they repel each other, kind of like trying to stick the wrong side of magnets together. That's going to cause these nuclei to break apart, unless there's something to hold them together. And every particle in the nucleus contributes to a strong force known as the nuclear binding force. So, the more neutrons you stuff in with all those protons, the more nuclear binding force, or glue, that holds this nucleus together. We'll come back to that later, but it's an interesting point. All right, let's answer some questions about mass number now. What is the mass number of an element that has 20 protons and 21 neutrons? Well, that's some really complicated math. Let's try it. Let's see, 20 plus 21. I got 41. The mass number is 41. So what's this atom called? I'll wait while you get out your periodic table and look it up. Are you looking it up? Maybe I'll just tell you. All right. So a lot of students get confused with this too, and they go looking for element number 41. But remember, this particular atom has 20 protons. That is the atomic number. So instead of looking up element number 41, let's find element number 20. It's a little element that we call calcium. However, that name in itself is not enough because, as we're going to see later, there are different kinds of calcium atoms. There are different numbers of neutrons that can go along with this 20 protons. So what we do when we name it is we give it a more descriptive name and call it calcium 41, the name of the element along with the mass number at the end. All right, this leads us right into the concept of isotopes. Let me show you some pictures of some atoms before I tell you what isotopes are. Here's my first picture, and what do you think this atom is supposed to be called? Yeah, this one's easy. It's got one proton. Element number 1. Are we looking it up? Hopefully you know this already. The first simplest element is called hydrogen. Let's try another one. How about this model? Here's an atom that has a proton and a neutron, and it is called... Did you say helium? Because this is not helium. This is also called hydrogen because it's got one proton. And my third picture. No, it's not lithium. This also has one proton, so we call it hydrogen also. All right, you can see the problem with this. These are all called hydrogen, but they look different. And so what we do when we name them is we give them a descriptive name, hydrogen 1 for the first isotope, because there's one thing in the nucleus. Hydrogen 2 for the second, hydrogen 3 for the third. And again, these numbers aren't just random numbers. This is the name of the element followed by the mass number. All right, now I can tell you what isotopes are. Those were examples of isotopes. Those are atoms that had the same number of protons, but they had different numbers of neutrons. They're all the same element, but they have something different about them. And the thing that's different is not the properties. Those behave the same way. The thing that's different is the mass. So some of those isotopes were heavier than the others because of the extra neutrons added. Otherwise, they're identical. All right, the last thing I'd like to show you is how we notate these, and we're going to call this notation nuclide symbol notation. As you look at this symbol, I want you to notice a few things about it. First of all, the biggest and most obvious part of this symbol is the elements symbol. If you've been with me for a while, you've probably already memorized about 40 of these, at least you were supposed to, and so you probably already recognize capital C, lowercase l is the symbol for chlorine, right? Now, an important point here is these symbols are always capitalized, and if there's more than one letter, the second letter is always written as a lowercase. Next, we're going to move around to this number on the bottom left, called the atomic number, also known as the number of protons. This number we can find on the periodic table. Look up the symbol, Cl, and you'll know the number, 17. The number on the top is the one that sometimes varies. Sometimes chlorine has 37 protons and neutrons, but other times it may only have 35 or other numbers of protons and neutrons. Remember, this is what makes up what we call the isotopes of chlorine. This particular one has a total of 37 protons and neutrons. So with a little math, I bet you could figure out how many neutrons there are. Man, you are good. That's right, 20 neutrons. All right, now I want you to write your own symbols for some elements. There are two nuclides described at the bottom, and I want you to take out your own pencil and piece of scratch paper. Try writing the symbols for these. Go ahead, take out your paper. I want you to pause the video before I show you the answer, and that way we can compare. Great. So for the first symbol, you looked it up on your periodic table and found out if there's 22 protons, it's got to be titanium. You added some numbers around it and came up with Ti with a 22 on the bottom and a 46 on the top. Great work. So what about the second symbol? Well, you should have gotten the same symbol, Ti with a 22 on the bottom. The difference is the number on the top is a 48. And what do we call these two elements? They have the same number of protons but different numbers of neutrons. That's right, these are isotopes. All right, let's try another one. How many protons, neutrons, and electrons are in this element? Why don't you pause the video again and see if you can figure it out without getting my help. All right. So it looks like there's 42 protons. We get that from the number on the bottom, called the atomic number. There are also going to be 42 electrons because at this point we're looking at atoms which are always neutral, and so the protons and the electrons should be the same amount. Finally, you do a little math to figure out the number of neutrons, and you got 53. Nice work. 53 neutrons. All right, let's try another example. How many protons, neutrons, and electrons are in this element? Well, now this one looks a little harder because there's no number written on the bottom. But that's okay. There is a symbol. And if we can figure out that number on the bottom, the number of protons, I bet we can figure out all the other numbers. So how do we find the number of protons? We get out our periodic table. We look up symbol K on the left side of the periodic table. We find the atomic number at the top, which is 19, and we fill that into our little symbol here. Now there's 19 protons, which means there's 19 electrons, and a little math tells us 21 neutrons. Aren't these fun? So in this brief lesson, we've talked a little bit about what atomic number is, what mass number is, and how we represent symbols for these different nuclides. We've also looked at the definition of an isotope, and in our next lesson we'll see how do we use isotopes of an element to figure out its atomic mass. Hope you learned something. Now, go do your homework.